Hello, Harsh.
Hello. Sir, can you hear me?
Yeah, I can hear you. So
Sir,
we have completed this now. We have
just a minute. Yes, sir, we have completed the properties of equipotential surfaces.
So there are two more points. There are two more points here.
So just a minute, sir, just a minute.
No problem. Because I want that you should leave some space for point number second and third. Okay.
Yes, sir, you can continue, sir.
Harsh, are you okay?
Yes, sir.
Should we start?
Yes, sir.
So please leave some space and write new heading, potential energy.
Okay, sir.
Do you know what about the potential energy?
Yes, sir.
What is potential energy?
Like the
Potential energy.
definition.
Anything you can tell, definition and formula.
Sir, it's the hidden energy.
Actually, the potential energy is the energy of body due to its position. Like suppose here is a pen. Okay,
Yes, sir.
this pen now, I am supposing this as a ground. This my
Yes.
palm is a ground and this pen is placed here. This have a no potential energy. As I move this pen like this, as I move this pen like this, the potential energy will be stored in this pen.
Okay.
And now see why this happened, because what we have done. Let's see what we have done. This pen has some weight.
Yes, sir.
This weight is acting in downward direction.
Yes, sir.
This weight is acting in downward direction, and we are doing doing the work. We are doing the work in taking the pen from this position to this position,
Yes,
and
sir.
this work is stored in this pen as the potential energy. Let's see.
Sir, so
Hmm.
we can say it's a hidden energy of
Hmm,
object due
hmm,
to its
hmm,
position.
hmm. This is the hidden form of energy.
Yes, sir. Okay.
Now I will explain you. Actually, I have done the research on this topic.
Okay.
Let's see. This is the ground,
Yes, sir.
and suppose here potential energy is 0, and here is a body of mass m. And what we are doing, we are taking this mass to this position. I am eating because I am taking classes from continuously 4 hours.
Sir, of course you can eat, sir.
So we also require some potential, not
Yes,
potential
sir.
energy, but energy.
Yes, sir.
We require energy now
Yes, sir.
from food, and we are also studying the energy.
Yes, sir.
So let's see. Suppose I have taken this mass at a height h. So in the process, what happened? In the process, what happened? Let's see. When we are taking when we are taking the mass upward, when we are
Taking the
taking the
mass
mass,
upward.
like when the mass is here, suppose the mass is in between. So the force is like this,
Yes, sir.
force mg,
Yes, sir.
force in downward direction, and the displacement of this mass is in the upward direction.
Upward.
So means we are doing the work against the gravity.
Yes, sir.
Gravity is in downward direction, na
Downward direction,
mg.
and we are picking it upward.
This is gravity actually. Mg is gravity, force of
Yes, sir.
gravitational force. This is
Yes,
gravitational force,
sir.
and we are trying to doing the work against the gravity.
Yes, sir.
And this work is equal to potential energy. This work is stored in this body. In this body now stored work.
So we can say like work done against the gravity is potential energy.
Yeah. You can say in an improved way, like work done, work done in moving a body from one position to another
Against the gravity.
against the gravity is stored in the body in the form of potential energy.
Okay.
To leave that, this is just for understanding. This is
Yes,
the
sir.
topic. This is the topic of 11th class, and chapter is work, power, and energy.
Yes, sir. I learned it, sir, last
Yeah,
year.
very good. So
11th, sir.
yeah, so cause of potential energy. I am writing potential energy as
Yes,
P.
sir. Yeah, P.
Okay. So cause of potential energy is conservative forces. Okay.
Yes, sir.
Conservative forces of interaction. In the earlier case, the body was on the earth now
Yes,
initially,
sir. Yes, sir.
and we are taking the body upward. So there is a force of attraction. There is a force of attraction between this body and earth. You have, maybe you have studied in your 11th class. This is known as gravitation force.
Yes, sir.
And this gravitation force is conservative.
Yes, sir.
Conservative is, I will tell you what is
Ground.
conservative force. So this gravitation is conservative. Whenever there is a conservative force interaction, there will be the potential energy.
Okay.
Okay. So there we have mass. There we have mass. Now we have charges.
Yes.
So you can write the example of conservative forces. Conservative forces.
Yes, sir.
Number one is gravitational force. Gravitational force is a conservative force.
Yes, sir.
And second is electrostatic force. Electrostatic force means the force due to Coulomb that we have studied by Coulomb's law.
Yes, sir.
Means the force between 2 point charges is conservative.
The force. Yeah.
Okay.
Yes, sir.
So I have told you the force is conservative and there are conservative interaction between the charges. So there
And
will
that's
be a
potential energy.
that will generate potential
Potential
energy
energy.
somehow. Okay.
Yes, sir.
And I am saying here, writing here ETC.
Okay.
And one thing more, potential energy is not defined. Only change in potential energy is defined.
Defined.
Like I am writing here, change in potential energy is equal to work done by external force, which is equal to negative of work done by internal force, which is equal to negative of work done by conservative force. And this change in potential energy is written as delta U. This is from 11th class. So we should only remember change in potential energy is equal to work done by conservative force, negative of work done by conservative force. So why I am telling these things? Because we have to study the potential energy of a system of 2 point charges.
Yes, sir.
What we are going to do, let's see. What we are going to do, we are taking 2 point charges, and
Yes, sir.
we know that there are the force of interaction between 2 point charges,
Yes, sir.
and due to that force of interaction between the charges, somehow the potential energy will be stored in the charges, like in mass we have studied earlier. Okay. So let's see how this will happen. There are two, write the heading. Potential energy. This is our main topic. Potential energy of a system of a
Charges.
system of 2-point charge. Two-point charges means first I will write the definition and after that I will explain. This is potential energy is work done in carrying charges from infinite separation to their respective position. Get stored in it in the system, in the charges you can say, or in the system. In the of potential energy, or you can say work done to make a system get stored in the form of potential energy. So this is the definition. This is the definition part. So there is a term system. System is two interacting point charges. Suppose there is one charge here only, plus Q charge. Can I say this charge as a system?
No, sir.
No, I cannot say this single point of charge is system. I can say if there is any other charge also. Maybe, but at least one charge should be there.
Yes,
And
sir.
there are forces of interaction between these two charges.
Yes, sir.
So system is something in which there are conservative forces of interaction. System is something here in this case we can say system is
Something. We have conservative forces of attraction.
yeah. So now let's move very well. Okay. Now let's see. I am taking what we have saying that we are taking charges from infinite separation. Okay.
Yes, sir.
Let's see.
Sir, before we continue, can I write the above part or after it should I write?
Okay. You should write. Right.
So can you scroll down?
Completed?
Sir, just a minute, sir.
Okay, no problem. Give me 1 minute.
Yes, sir. Done, sir.
Okay. So this is the definition. And
Yes, sir.
definition is not enough for understanding a concept.
Of course, sir.
Actually, I believe that some definition uh, confuses the student instead of giving some information.
Yes, sir.
I personally believe that.
It
In
does, sir.
yeah, like in
Sir, you're muted, sir.
in NCRT, what happens in mathematics? When you are in 10th class, I was in 10th class. So definition confuses me.
Yes, sir.
So, but the actual work starts from here. Let's see. Now concentrate. This is infinity. We don't know where the infinity is. So in physics, we say infinity is a distance which is very far compared to the distance between two charges. Like
Yes,
if
sir.
distance between two charges is 3 mm, so 3 meter will be the infinite. 3 meter means 3 kilometer. 3 meter you can say infinite. Okay.
Yes, sir.
This is just a very simple concept. Like in physics, what we have done, if how we define infinity in physics, infinity means no one knows infinity.
No one. Yes, sir.
No one knows infinity. But in physics, what is the meaning of infinity is it depends upon the distance. Like you have two charges, these two charges, and you can take from the center of these two charges. If distance between these two charges is 3 mm, if you are taking 3 kilometer, that 3 kilometer from the center of these charges can be considered as infinite
Infinity.
in physics. So this is the infinite. This position P is infinite. This P is at infinite.
Infinite.
This is the sign of infinite. Like this is 8.
Yes,
This is
sir.
8 now,
Yes,
and
sir.
you this is so like this. And what happened now? What happened now? There is a person who want to make the system, and whenever we make the system, we have to spend some energy. You can see in the system. If you want to make a system in office,
Yes, sir.
you make sure that everyone should work properly. Or if you make a system in your house, like if you are a father, suppose you
Yes, sir.
if someone is a father and he wants to make a system means like he want to say that everyone should study and uh, put the things properly, so
Set
means
of rules.
set of rules, so means he or she will have to invest some energy now.
Yes,
He
sir.
have to do an energy related to work, means he have to do some work. After that work he can only make the system. And in physics also, when we are making a system of two charges, so we have to do the work. So now what we are doing, this person is taking a charge q1 from infinite and put the charge someone here at this position. Okay.
Yes, sir.
So, and in physics we consider potential. Do you remember na, was a term potential
Yes,
V.
sir.
Potential at infinite is 0.
Of course. Yes, sir.
This is V.
At
No,
zero.
this is considered in physics. Okay. So as to simplify the thing. So now let's see. This person what have done? Carry a charge on his back and leave that charge here. So
Yes.
how much work this person has done?
Work done.
Can you tell me?
Uh,
No work done. Work done is 0. Why? Now I am telling why.
how can work done be zero?
That's
Sir, because it's not against the gravity. It's not.
yo. Actually, one thing, Mona, now we are not in mechanics. We are dealing with charges. So here is no gravity and all that. Please remember this thing.
Yes, sir. Now it's charges. But still, sir, how can work done be zero?
Now I will prove that. Na,
Okay, sir.
you will see that. You know this formula? Q
Yeah.
into change in potential.
Yes, sir.
And please tell me what is the potential at point A?
Potential due to a point charge. KQ by R.
And what is R?
Distance.
From where you will measure the distance? Suppose
Yeah, we have infinity. Right?
actually you see the thing. Actually, many student confuses. There is nothing here. This is all black portion, and there is nothing here, and there is only a single charge here. Uh, uh, there is a point here.
Yes, sir.
Okay, and there is a point here, and here is a charge is placed Q. And what is the potential at this point?
Potential at the point.
Yeah, potential. How we calculate the potential? Potential is produced by charge.
Work done by charge.
No, no, no. That is fine. You are saying right. You are saying right. But now, here at point A, potential is zero. But now, here is not the potential zero. Here is not. Here is not. Here, 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 here. Why? Because due to this charge, there is a potential at point B. We have the formula na
Yes, sir.
K
KQ
Q
by
by
R.
K Q by R.
Yes, sir.
K Q by R. And if I want to calculate the potential at point C due to this charge,
Yeah, so VC is equal to KQ by
KQ by this is R1, suppose this is R2.
R2.
Have you ever calculated the potential like this is a charge, and this charge is placed at A. Have you ever calculated? Please calculate the potential at point A.
I
Never,
know,
na?
no, sir.
No. So the potential is zero at the initial position. And if we
Oh.
apply the formula, what is happen? What will happen? See, V
So
equal to
for a test charge, potential is always zero.
yeah, for a charge at the if there is only charge there.
Yeah, okay.
If there is
Singular
only
charge,
charge there,
yes.
if only a single charge, then
Without
the
any distance or something is there.
you can say for a isolated charge. For a isolated charge, potential is always zero. Always zero. If someone is putting a charge Q here, then at point A the potential will not be zero.
No, it will be KQ by R.
KQ by R.
Yes.
So now thing is that if this is the formula, this is a point, and this is point position A, and here is a charge Q. And what is the potential if I will apply this formula KQ by R. And how we will calculate R?
So there
R
is
is
no
nothing.
distance.
There is no distance. If
So it
you
is
say
zero.
R is zero, then not R is not zero, na?
Everything is zero.
R is not zero because R is the distance from the charge. No?
Yes, sir.
Okay. If you take R zero, then what will happen? See. Actually, this is not valid in physics. This will be zero. And 1
It
by
will
0
be
is
infinite, right?
infinite. So potential at A will be infinite. But this is wrong.
Yeah, of course. Potential can't be infinite. Yes, sir. Okay. Got it.
But the moral of the story is that if there is no charge surround any other charge, if there is a single charge, here is a single charge, or
Yes,
here is
sir.
only a single charge, then you should say potential at the point A is zero.
Zero.
If there is no other charge.
Yes, sir.
So what will be the work done in carrying a charge Q1 from infinite to, so I am writing like this. Work done for carrying a charge Q1 this is very easy thing if you understand properly. Like you can see here. Work done in carrying a charge Q1. Which charge we are carrying? Q1 charge na?
Yes, sir.
And from where we are carrying this charge? From infinity to
a point.
A.
Yes, sir.
So we have a formula charge into change in potential. And what is the value of charge? Q1.
Yes, sir.
Change in potential means final potential, means potential at A minus potential at B. And what is the point B? Potential at point, this is, I am supposing this final point is P, na?
Yes, sir.
Initial point is P. This is P.
Initial is P, final is
So this is Q1. What is the potential at A?
Q. Oh, 0.
0. What is the potential at P? P is at infinity.
0.
0, na?
Yes, sir.
See that work done is 0.
Okay, sir.
That's how the work done is 0.
0.
So no work will be done by
Got
he
it,
will
sir.
be he or she will be very happy that without doing the work he or she have achieved something. But now let's see. Now let's see. We cannot make the system without doing the work. You have to do the work.
Yes, sir.
Now let's see how. Okay. So this is also a work. I am moving this image to here to here. Okay.
Yes, sir.
So now what happened? We have to make the system of 2-point charges. Suppose this person take 1-point charges from infinite to position A, and what he have done now, he have carried another charge Q2 at a location B. Q2 at a location B. Now in this process, what will be the work done? What will be the work done? Let's see. I have told you I have to calculate the work done in carrying a charge Q2 from infinite to position B. It means that we have a formula for work done, charge into change in potential.
Yes, sir.
And what is the charge? Here Q2.
Q2.
And change in potential means final potential.
So
What is the
minus
final potential?
Q.
Final
B.
potential is VB.
Yeah.
What is initial potential? VP.
VP. No. Yeah, VP. Yes.
VP because we are taking a charge from infinite.
Yes, sir.
And this VP is 0.
Yes, sir.
So we have work done Q2 into VB. And now, what is VB?
Q2.
VB is the potential due to this
Point A.
charge. The potential at point B is due to the charge at
At
A.
point A.
Okay. And we have a formula. Suppose this is at a distance R.
So KQ by R.
Hamza, give me a minute. So this is R, na? So potential at point B is, if you calculate the potential at point B, you will get KQ2 or KQ1?
It will be, no, wait.
No, potential is due to this charge. So we will
Yes, sir.
take this charge, na?
Q1.
Q1 divided by
R.
R.
Okay, sir. Got it.
We got it, na?
Yes, sir.
So we will simply put the value of PV here.
KQ1 by R.
Yeah.
So it will be.
This will be Q2 and we have KQ1 by R.
R. So it will be KQ2.
So this is the work done K Q1 Q2 by R from infinite to, and we want to calculate what I have told you. Work done means here is total work done. We are talking about the total work done. So if I want to calculate the total work done, means I will calculate, suppose I am supposing this as W1 and this is
W2.
W2. So work is a scalar quantity, we can add the work directly.
Work 1 plus work 2.
What is
So it will
W1?
be 0 plus,
But W1 is equal to 0.
yeah, 0 plus Q2 K Q1 by R.
K Q1 Q2
Q2
by
R.
R. So means total work done is equal to
K Q1 Q2 by
K Q1 Q2 by R.
R.
So I have told you now, for making a system we have to do the work, and that work will stored as potential energy.
Yes, sir.
So this is the total work done now, and we have the formula change in potential energy.
So this is Coulomb's law, right?
No, what?
Oh, so it can be written as Coulomb's law, right? Because it's K Q1 Q2 by R. Oh, it's R square. Yeah.
This is physics. What is
Yeah.
happening here? I have lost my control on the notepad. 1 minute.
So I think you should just minimize it and start it again.
But minimizing is not. Yeah. I don't know what had happened. Okay, please wait for 1 minute.
Yes, sir. I'm waiting, sir.
What happened? I don't know what happened. Yeah.
Sir, you may restart your device, sir.
Yes.
Is it working now?
Not working. I don't know. I
So,
think
sir,
I should restart that. Okay.
yeah,
So
you should restart it.
you should join the meeting once again. Okay.
I'll join into myself.
Okay. So now please leave the meeting, as my system is not working properly.
There is the problem solved.
Am I audible?
Yes, sir, now you're audible. Before you were not audible. So
Okay.
there is a problem solved.
Yeah, we will see. Here, what is- So, Harsh, what is the formula of work done?
Formula of work done.
Hmm.
Sir, wait. Uh,
The charge into potential
sir,
difference.
Q1,
अरे
Q2
यार,
by
work
R.
done, work done. So
Work
total.
done. So total, right?
हाँ.
Q1, Q2 by R.
Hmm.
Is that correct?
Yeah, you are correct. This is total work done,
Yes, sir.
and
Sir,
in the definition, what we have written, work done in carrying two charges from infinite separation to their respective position get
it's
stored in
stored
the
in the
system in the.
system from
So this
potential energy.
work done will get stored in the form of potential energy. Okay.
Okay, sir.
So
Sir, can I write this?
okay, of course. From where you want to write?
Sir, from here, sir.
So let me complete after that.
Okay,
Right.
okay. Yeah.
Okay. So change in potential energy is equal to, we have already discussed that, change in potential energy is equal to total work done. And the change in potential energy, final potential energy minus initial, and this is equal to total work done. What is the initial potential energy of the system?
0.
Zero. Very good. And work done we know.
Yes, sir. Q1, Q2 by R.
So I am writing UF as U. Okay.
Yes, sir.
This is capital U. So we have K Q1 Q2 divided by R. This is the required formula. So
Yes, sir.
potential energy of a system of two charges is given by K Q1 Q2 divided by
R.
R. Potential energy of.
Sir, this is different. Electrostatic potential energy is different, right? U
Yeah,
is equal
yeah,
to
yeah,
QV.
yeah, yeah.
That's for a
Actually,
point charge.
we are dealing with electric force.
Yes, sir.
So due to this electric force, there will be a electrostatic potential energy.
Yes,
Okay,
sir. Okay, sir.
you can write here also. Electrostatic potential energy of a system of two charges.
Okay, sir.
And one thing more, if I am writing here like there is one Q1, there is another charge minus Q2. So we will take the charges with sign K, Q1
Q1
and minus
minus
Q2
Q2 by R.
divided by
R.
R. Because this is the scalar quantity. Okay.
Yes, sir.
So please now note it down.
Yes,
And
sir. Second scroll up. Sir, up. Yes, sir. From here, from little bit down. Yes, sir. From here.
should I scroll down?
So just a minute, sir. Sir, you can scroll down, sir. Done, sir.
Completed?
Yes, sir.
Okay. Give me a minute. Okay, Harsh.
Yes,
This is
sir.
all about the electrostatic potential energy and this is the derivation.
Yes, sir.
Now write one question.
Sir, we should find the potential energy.
Yeah.
Okay, sir.
You can write electrostatic potential.
Yes, sir. So we should use the formula K
And
Q1
and
Q2
please
by R.
please okay, and please tell me the answer.
Yes, sir. Just a minute, sir. I'll tell you the answer.
Okay, no problem. We have a formula U
K
is equal
Q1
to
Q2 by R.
value of
So that
K
is
is
1 meter, right?
yeah.
Okay. So just a minute, I'll solve it.
Okay, no problem. You can also solve. R is 1 minus 27 into 10 to the power
There is minus
9
27 10 to the power minus 9.
9 joule. Okay.
Yes, sir. Got it.
So can you solve more questions?
Yes, sir. I can.
Okay. So now should I move?
Yes, sir. You can move.
Now suppose here is a cylindrical conductor. Okay. And these are ion, these are electrons. These are electrons. They are free electrons. These free electrons help in conduction. Okay.
Conduction.
And we will study this in our next chapter, current electricity. How the electrons helps in conduction.
So only in this chapter there is capacitance, right?
Yeah. This is the name of the chapter is.
Electric potential and capacitance.
After that we will study current electricity.
Yes,
Okay.
sir.
So ions are not moving because they are
Helping.
not moving because they are heavy. And this is cylindrical conductor. This is easy, na?
Yes, sir.
Here you don't have to think much, but here you have to think. And now properties of conductors.
Sir, just a minute, can you scroll up? 1 minute. Yeah. Okay. Just a minute, sir.
Okay, no problem.
Done, sir. Done. You can continue.
Properties of conductors. This is very easy topic. Suppose here is a conducting sphere. and I have kept a charge on the center of this conducting sphere plus Q charge. What will happen?
A charge is kept in a conducting sphere.
At the center of conducting sphere.
Yes, sir.
I have told you this many times.
Sir, surface, you'll have charges on the surface, right?
What?
Like what will happen?
Due to induction, this charge will move on the surface.
Surface,
Whole
right?
charge.
Yeah.
And there will be no charge inside
The
the
inside charge is
conductor.
present on the surface of the conductor. So then I told the correct answer.
Now there is no charge.
Yeah.
In the conductor.
Yes, sir.
The whole of the charge. Okay.
Yes, sir.
So from here we can say this is conducting sphere. This is conducting sphere, and I have given a chart to this, and charge inside the conductor is 0.
Yes, sir.
So from here we can write our first point. Charge inside the conductor is always 0.
Yes, sir.
Why 0?
Sir, because because all charges are always present on the surface of the conductor.
Okay.
Like, is that the reason?
Yeah, this is the reason. But this happens due to another reason that is known as induction.
Induction?
Yeah.
I didn't study that in the last.
Okay, no problem. You will study this. But this thing is clear now.
Yes,
charge
sir.
is inside. Charge inside the conductor is 0.
0.
Reside on the
surface of the conductor.
Very good. So this point is clear. So as the charge is always on the surface of conductor, so we will always take surface charge density for conductor. Okay.
Yes, sir.
What is surface charge density?
Surface charge density.
Charge per unit area.
Yes, sir.
The amount of charge on the surface
per unit area.
Okay. Surface charge density. Harsh, are you revising your notes properly?
Yes, sir. Like, sir, I have revised. Like, because this chapter came in the unit test also.
Okay. So this point is clear. Our second point is what about the electric field?
Perpendicular.
Yeah.
Perpendicular direction of the.
Let me complete the question. Actually, I am asking what will be the electric field inside the conductor.
Electric field inside the conductor
is 0.
0, right? Because there's no charge present.
Yeah.
I thought you were asking the direction of the.
Let me complete the question and after that.
Sir, but direction is perpendicular, right?
Yeah. We will have that point also.
Yeah, it's there. I remember. That's why I thought you told electric field, so I have to say perpendicular.
Okay, no problem.
Second,
Okay. What do you want to say? Please tell me.
like sir, after writing this one, can you just scroll up after writing this one?
I have completed this point.
Can you just scroll up? Yeah. Thank you, sir. That's it. That's it.
Fine.
Yes, sir. You can scroll down. So yes, sir. You can continue. I wrote the point.
So, Harsh, now your point that you were saying. Third point. Electric field is always perpendicular
Perpendicular.
to the surface of conductor. Okay.
Yes, sir.
Always
Perpendicular.
so Harsh, this is the conductor. This is the conductor. This is the spherical conductor,
Yes, sir.
and I have told you the electric field is perpendicular to the surface of this conductor.
Yes, sir.
Always.
Yes, sir.
Okay. This is spherical conductor. Like this also you can see. Okay, Harsh.
Yes, sir.
And this have a charge also. And so Harsh, uh,
Yes, sir.
that's all for today.
Okay, sir.
And Harsh, so please tell me what is charge.
Second, repeat the question.
What is charge?
What is charge? Sir,
It is
it is a type of energy.
yeah. No.
No, wait. It's not energy. It's sir. How do you define charge, sir? Sir, 1 minute. 1 minute. Sir, it is a intensive property of matter which give to electric force, which give rise to electric force. Sir, can you hear me?
Suppose this is a charge q na,
Yes, sir.
and I want to calculate the potential at a distance r at point B. What will be the formula?
So one minute. Can I repeat the question? We have to
This is a
calculate.
point. This is a point charge,
Yes, sir.
and I want to calculate the potential at point B at a distance r from it.
Okay. So it will be K
Harsh, what are you doing here? KQ by R.
KQ by R, yeah. Point charge. So did I lag? I told the formula, right?
Okay, no problem. Please revise your notes, and thank you for joining. And now you can leave the meeting. Please revise, please. Okay.
Yes, sir. Bye, sir. Thank you, sir.
Fine. Hello, Hamza. Am I audible, Hamza?
Yes,
Okay. So how are you?
sir.
How was your party?